Hi there, Dave here with a video about our tip calculator program. In fact, actually 3 versions that do exactly the same thing. Let's take a look at them. Here's the first one, and this one has got no module in it. The second one we'll see has got a module done the right way, and the third one's one I don't like, but can be done. And the book talks about it. So, here we go. We've got one output variable, which is the total tip, and we've got input variables, item type, item cost, and item tip percent. And we're going to reuse these variables, so we'll show you that. And so the first thing we're going to do is we're going to declare all of our variables, and then we enter the item cost, and then I get the, item type, and I get the type, and then I display that type and I ask for the cost. And then I input the cost, then I display the type again and ask for the tip percent for that. And then I take that in, and then I calculate and I say, well, so far the total tip is equal to the cost times the percent. And then we basically do that again. So we say, okay, enter the type, you reuse the variable, it's okay, now it's pointing to the new type. We know it's an immutable string, it's pointing to the new type, and the old one's still pointing to the old one. And there we have, but we don't need it, because we're reusing the reference name. So here we have the cost, and we're displaying the item type that we just took in right here, and saying, okay, it's cost, and it's percent. And now we're saying that the total tip is equal to the total tip, what it used to be equal to, plus the current value of the item cost times the item tip percent. We know that these are immutable types. So now the total tip is being set to after this is done. And we know that these types are immutable types, right? So this actually is a different location in memory than this one was, right? Because when this one was calculated, it became immutable, and then when this one is calculated, it's in a new place. But the effect is that total tip is now equal to what it used to be up here, plus the current value of this times the current value of this. So, and then to do it 3 times, which is what we said we wanted to do it, we just do it a 3rd time. We do this exact same thing again. So whatever they enter for the 3rd type becomes, okay, cost and percent. And well, we could do this as many times as we wanted. And eventually we're going to learn about how we do loops and how we could possibly end these loops and other things, but that's later. So here we go. We ask for the 3 types, and then we say down at the bottom that the total is equal to that. We saw what happens in class. It just prints the total, and it does it correctly. Well, that's straightforward, but you can see that you'd have to repeat this for as many as you wanted to do. You'd just be repeating the same code, and it's dumb. So we should be a little bit more clever than this. So we're going to do a module, and I'm going to show you the right way to do it, which is how we did it in class. And because I think it's important to write good code, and this is the kind of code that you want to write in the real world. So we'll see it's pretty much does the same thing. It does exactly the same thing, actually, if you run it. Same variables, no problem. This time we have a module, and it's going to return a real value, and it's called calculate tip. And that module has got the type and the cost and the percent. And that module asks, okay, give me the type, give me the cost, give me the percent. And then it returns, the module returns, because a module can return one thing, a function, a procedure. They're all the same idea, different languages. So this module is going to return the item cost that it just took in times the percent. That's what that's going to do. Now we've executed up to this point. We've done absolutely nothing. We've executed nothing except we've taken in this particular module so it can be used. And so the code is, okay, we'll go ahead and declare the total tip. And then we'll go ahead and we'll set the total tip equal to calculate tip. And so we're going to execute calculate tip, and whatever result is given back, we're going to put into total tip. Well, yeah, that's exactly the first thing we did in the first module when we did this part, right? That was this part here. And now, that was that part. And now we just execute that module again, but we take its results. This time we take the results of calculate tip, where it asks us the item and the cost and the percent, and returns the tip. This time we add it to the total tip. So we're taking the total tip and the value that was here, right? This value, which is immutable, and we're adding to it the result of executing this, because it gets replaced by the value that's returned. And we add those two together and we put it into a new place in memory, but we point the label, the total tip, at that new place in memory. And then we do it one more time. And we're done. This is a much more elegant way to do it. We're not repeating code all over the place. And you'll see that it's much more useful for real-world problems. When we come down here and look at the code, well, it does exactly what the pseudocode says. Otherwise, the pseudocode is no good. So the first thing is the definition of the module. So it's called calculate tip. And there are the declarations of the variables, setting type to a string, a null string, a string with no length. Setting the cost to a float with 0, and I set it to a float by making it 0.0. And so I make the percent also. And then I go ahead and take these things in, and here's how I print the item that I entered for its cost, like that. And then I go ahead and I return the item cost times the item tip percent. Of course, we have to convert them into float because they were strings coming in. And then we want to divide by 100 because I asked for the percent, not for 0.10. I asked for 10. So we have to divide by 100. And so calculate tip does exactly what the pseudocode says. And then down below here, all we need to do is, according to here, we declare our tip. Then we go ahead and we set the total tip equal to the first execution of calculate tip. And then we set it equal to what it was equal to plus the second execution of calculate tip. And then we do it one more time. And when we're done with that, we go ahead and print the total. And so here is another way to do this, which I call the bad way. This is using global variables, and global variables are nasty bad things. And even the book says that they're not really a good idea, but then it shows you using global variables actually quite a bit here and there. So I'm not going to use them, but I will show you, because you do need to understand about global variables and how they're used and how they're used in Python. The book assumes that you're not using Python. It assumes that you're using a language where you define a global variable inside of the main program. Python doesn't do it that way at all. Python, if you're going to have a global variable, it is defined inside of inside the function. It said, okay, this is a global, and it's just like the one that's defined outside of me. And so, let's see if we can figure this out. The code looks exactly the same, except notice that instead of setting a value equal to the execution of calculate tip doesn't return anything. And notice that it just says module calculate tip. And so the module is the same, except it doesn't return anything. What it does is it sets total tip. So it's using the fact that it knows total tip is going to be set to a global variable, which means that it's available to all modules, at least all modules that reference it in Python. Global variables are not cool. So that's why I'm not going to I'm going to do this one, I'm going to do one more, and then we're going to stop talking about global variables and do it without using global variables. So we are incrementing a variable here that was not passed into us. Because look, total tip is not here. It's up here. But it's global. Okay, so that we can get away with this kind of thing. Let's take a look at how we pull this off in Python. Well, up at the top, we still have our calculate tip. There's our calculate tip. It looks the same. And there we go. We ask for, oh, look at this. There, that sits all by itself. Global total tip. What that means is that total tip here is defined outside. Where is it defined outside? There, it's defined there. It can even be below the definition of. All that says to Python is, hey, it's going to be defined later on. Don't worry about it. It's going to point, so compile. So this global says it's going to be the same name. Go find the name and make that a shared reference. Which means that I can change total tip in here, and it's going to change the value of total tip in the main program. So here we set total tip to 0, and then we just calculate total tip 3 times. And that's all going to be good because, in fact, total tip is going to be incremented each time. The first time is set to 0, so it'll be adding to 0. But this is what it's going to do each time. It's going to take total tip and add to it inside of calculate tip, right? So once again, this global says this guy is the same as something is going to be defined. Oh, there it is. It matches up. So these are the same variable. Anything that I do to that variable, even though it's defined out here, anything that I do to it inside of here will take effect out here. Like I said, there are much better ways to do that. All right. Take care.